More than 30 years after Hubble made his observations, cosmologists remained divided about whether the Big Bang theory was correct. More evidence was needed, and it came in the 1960s with the discovery of a mysterious faint signal. We call it the cosmic microwave background radiation. It's seen as a faint glow, coming literally from everywhere in the sky, and not being emitted from any particular star, galaxy, or object.
So this is the oldest light in the universe. There are photons that have travelled 13.8 billion years from over there and 13.8 billion years from over there, and they're carrying information about the beginning of time.
One of the many remarkable things about the cosmic microwave background is the story of its discovery, because it was found entirely by accident.
We had this result. We couldn't find any explanation for it. We couldn't make it go away. What were we going to do with this thing?
So where did the cosmic microwave background come from? And why do we consider it such strong evidence for the Big Bang theory?
So the picture is this. The universe is expanding and cooling. In the first few minutes, it's extremely hot. And then the universe is filled by what's called a plasma. So it's too hot for atoms to form. 380,000 years after the Big Bang, it's cool enough for atoms to form. The universe becomes almost instantly transparent, so light can travel in straight lines, and it will continue to travel in straight lines for the rest of the expansion history of the universe, and it can enter our telescopes here on Earth 13.8 billion years later.
The cosmic microwave background is considered such strong evidence, in large part because the Big Bang theory predicted that it should exist.
It was first observed in the mid-1960s, and it's only then, really, just before I was born, that the idea that the universe began at a hot, dense origin really took hold. It's an almost overwhelming piece of evidence because you're seeing the afterglow of that earliest of times. We can take pictures of that light in great detail now. We just don't see it as a hum. We can photograph, essentially, the universe as it was, the whole sky, looking out into the universe, and see it as it was when that first light was released.